Let's solve this question here. Given sine 2x over 6 equals sine 3x over k, where k is positive integer. Find the value or values of k. So how do we approach this question here? Now first of all, let's write this out. Sine 2x over 6 equals to sine 3x over k. Okay, so that's the given in the question. Okay, so the first thing is maybe what you want to do is trying to put the same similar terms together. So I will move k here and then move sine 2x here. So multiply both sides by k and then divide both sides by sine 2x. And I will have this. K over 6 equals to sine 3x over sine 2x. Now, we cannot just compare sine 3x with sine 2x here. What we have to do is rewrite sine 3x and sine 2x in terms of their trigonometry identity, in terms of sine x. Then we can try comparing them together. Okay, so k over 6 is equal to, okay, what's the trigonometry identity of sine 3x? What is it in terms of sine x? It will be 3 sine x minus 4 sine cube x divided by, what's sine 2x in terms of sine x? Well, actually also cosine of x. That is 2 sine x cosine of x. Now, right away, we can see that we have a common factor of sine x. So we can factor sine x out of the numerator and also sine x out of the denominator. Then we can cancel it out. Okay, so k over 6 is equal to, now this is sine x times 3 minus 4 sine square, or sine x square, or sine square x, divided by sine x times 2 cosine of x. Now this sine x and this sine x cancel out. What we have left is k over 6 equals to 3 minus 4 sine square x divided by 2 cosine of x. What do we do next? Now, it's not too good to have sine x on the top and cosine of x at the bottom, right? Because they cannot cancel out. But what can we do? Now, it's a lot easier to rewrite sine square x in terms of cosine of x instead of rewriting cosine of x in terms of sine x. So I'm going to rewrite sine square x in terms of cosine of x. And we do know that sine square x is equal to 1 minus cosine square x. So I'm going to write that. K over 6 is equal to 3 minus 4 times 1 minus cosine square x. Now this is the same as sine square x over 2 cosine of x. Okay, so now distribute the 4 to each of this. We have k over 6 equals to 3 minus, now 4 times 1 is 4, minus minus become plus. Now 4 times cosine square x is 4 cosine square x divided by 2 cosine x. Now 3 minus 4 is just negative 1. So I can rewrite this as, now k over 6 equals to 4 cosine square x minus 1 divided by 2 cosine of x. Now what do we do next? Now looking at this term here, or this fraction here, we have cosine square x, and we have cosine x, we have a constant. Maybe we can rearrange it into a quadratic equation. So I'm going to cross multiply right now. So 2 cosine x times k is 2k cosine of x. Now 6 times 4 cosine square x minus 1 is 6 times 4 cosine square x minus 1. Now distribute the 6 to each of these. 2k cosine of x 2k cosine of x is equal to, now 4 times 6 is 24, cosine square x minus 6 times 1 is 6. Now subtract 2k cosine x from both sides, we have 0 equals to 24 cosine square x minus 2k cosine x minus 6. Now we have a quadratic equation to solve. Okay, and in this quadratic equation, the a value is 24, right? The b value is negative 2k, and the c value is negative 6. Okay, now what should we do next? I think we should try to find the solution to cosine of x, right? Then to see how many possible solution or roots it can have, and that will give the value, right? K, right? Well, to do that, we pretty much have to factor this quadratic equation. And how do we do that? Now think about that. We can just do this, right? There's a common factor of 2 here. We can factor the 2 out. So 0 equals to 2 times, this will be 12 cosine square x minus k cosine of x minus 3. Okay, now let's factor this. So we have to think of two numbers, right? When you multiply together, gives you negative 36, right? Because it's this times this, right? And when you add together, give you negative k. So what would be these two numbers? Well, let's call this m and n for now. Now, let's write this out. When m times n should be negative 36. But m plus n should be negative k. Okay. Now, in the situation, one of them should be positive, the other one should be negative. Well, it looks like that way, right? And if the sum of these two numbers is a negative number, then I guess the absolute value of the negative number should be greater than the absolute value of the positive number in this case. So what would that be? Let's think about it. Okay, so I guess 1 negative 36 will work, right? Okay, then what will be next? 2 negative 18. And then 3 negative 12. 4 negative 9, right? As if you add this pair together, they're all negative number. And then maybe 6 negative 6. What if you multiply each of these pair together, give you negative 36. Now, are there any more? Let's say 7. No, it's not divisible by 7, right? A is not divisible by A. 9. Well, if you have positive 9, negative 4, then the sum of this will be positive. But we have to have negative, right? So that means, okay, that's it, okay? Now, this is assuming that both m and n are integers. Now, notice that in the question, it says that k is positive integer. But that doesn't mean that m and n also need to be integer. So they could be decimal numbers. And if they multiply together, give you negative 36, that's fine too. But can that be possible? Now let's think about this. Consider if m and n can be decimal numbers. And if so, right, m and n need to have the same decimal places and decimal value. In order for this to work, right? Because m plus n has to be a negative integer. So that means they need to have a same decimal place and same decimal value so that it cancels out, right? And they have to multiply together to become negative 36. Can that be possible? Right? Can m times n result in an integer? Or I should say negative integer. Because we're looking for negative 36, right? Okay. Now, let's think about that. Let's say let B and E be both be an integer. Okay. Let's say not doesn't matter positive or negative. Okay. Let's be integers. Okay. And B over E is a decimal number. Okay, so that means D is not divisible by E. That's why it has decimal, right? And D over E is already at its most reduced form. So it cannot be simplified further, okay? Then, right, because D over E is a decimal number, and I need to have two numbers with the same decimal value and same decimal places to multiply together and see if it can get me a integer, right? So a better demonstration is square D over E, right? So D over E square, right? And that's equal to D over E times D over E, right? Because D over E has a decimal value. If I'm square it, obviously it's some same decimal place and same decimal value multiply itself, right? Which is going to illustrate the situation for our cases here. Okay, like I just said, D over E is already at its most reduced form. So that means D over E times D over E cannot be simplified any further, and there's nothing to cancel out. And that is equal to D squared over E squared, right, as an end result. But in that case, it will still be a decimal number, right? It's still a decimal number. Okay, so what does that tell us? In our case, in this case, right? Therefore, in this case, m and n cannot be decimal number. Okay. Now, since m and n cannot be decimal number, and we did say that k has to be positive number or positive integer. So we only have these values here that we can be considered as potential values. Okay. So we can write this now. Potential values of k would be okay, so because this number plus this number equals to negative k in this case, right? So we can say that, okay, so negative k equals to 1 plus negative 36 equals negative 35. Then we can say that k is equal to 35, right? Because negative cancel out. Negative k equals to here, this pair. 2 plus negative 18 equals to negative 16. Then k is equal to 16. Negative k equals to this pair. 3 plus negative 12 is equal to negative 9. Then k is equal to 9. This one here. This pair. Negative k equals to 4 plus negative 9. And that's equal to negative 5. Then k is equal to 5. This pair here. Negative k is equal to 6 plus negative 6. That's equal to 0. Then k is equal to 0. Okay. Go back to the question here. K is in the denominator. Then k cannot be equal to 0. So we have to say that k cannot be 0. So this one will not work, okay? So only this 4 potential value. Okay. Does it mean that this 4 value will definitely work? That may not be. We have to verify it. Now, in order for this to work, these roots here have to actually give a solution to the cosine of x here, right? So basically, that has to have a value for x in order for these values to be the value of k that work, okay? Okay, so what I have to do now is write the factor form out and then try to figure out what the potential value is for cosine of x. Okay, so let me do it here. Okay, here. Okay, so the first pair, 1 and negative 36. Now, since we know that there's a leading coefficient, right, in the front, so we have to do this. Okay, so let's draw a chart here. So the top will be negative 36. The bottom will be negative k. First pair, 1 and negative 36. Okay. So what we have to do is take these two numbers, right? Divide by the leading coefficient, which is 12. Negative 36 divided by 12. Okay, here. We need to remember this. The leading coefficient is 12 here, okay? Because we already factored the 2 out. Okay, now. And then, right, in the most reduced form, 1 over 12 is already the most reduced form. Negative 36 over 12 could be negative 3 over 1. Okay, so now, our factor form can be 2 times, now, this is the coefficient here, 12 cosine of x. Now, plus 1 times 1 times cosine of x is cosine of x, minus 3. Okay, so that would be the first possible factor form, right? Then in this case, right, 0 is equal to, right, divide both sides by 2 is still 0, right, on this side, right, on the left side. And that will be 12 cosine of x plus 1 times cosine of x minus 3, okay? Then what we can say is 12 cosine of x plus 1 is equal to 0, or cosine of x minus 3 is equal to 0. Okay, now we have to see, is there a value for cosine of x? In that case, 12 cosine of x is equal to negative 1, right? We subtract 1 from both sides. Then cosine of x is equal to negative 1 over 12. Then x is equal to cosine inverse negative 1 over 12. If you put that in the calculator, right, you will get 94.78. How about this one here? Now, to be honest, as long as one of them work, that's okay. But let's do it as well, right? So add 3 to both sides. Cosine of x is equal to 3. Then x is equal to cosine inverse 3. Right? If you put that in the calculator, it gives you undefined. Okay, but anyway, one of them work. Okay, so we can keep that potential value. Okay, that pair is basically 1 plus negative 36 is negative 35. So this potential k value is 35. Okay, now next pair. Let's draw the x chart here. Negative 36 and then negative k. So what is next pair? That would be 2 and negative 18. So 2, negative 18, right? Divide each of this number by the leading coefficient there was 12, right? After factoring the 2 out. So we have 2 over 12. This will be negative 18 over 12. And then write them in the most simplest form. And that 2 over 12 will be 1 over 6. And negative 18 over 12 will be negative 3 over 2. Okay, now write the factor form. 0 equals to 2 times, now this is 6 cosine x plus 1 times 2 cosine of x minus 3. That's another potential factor form. Okay, now in that case, divide both sides by 2. You have 0 equals to 6 cosine of x plus 1 times 2 cosine of x minus 3. Okay, again, right? That means 6 cosine of x plus 1 is equal to 0. Or 2 cosine of x minus 3 is equal to 0. Now, make sure we have a value for x here. So let's try to figure it out. So in this case, subtract 1 from both sides. We have 6 cosine x equals to negative 1. Cosine of x equals to negative 1 over 6. Then x is equal to cosine inverse negative 1 over 6. Right? If you put that in the calculator, you will get approximately 99.59. Okay? So these are just rounding values. Okay? Not exact. Okay. Like I said before, as long as one works, it will be fine. But let's do that as well. Let's see if it works. So add 3 to both sides. 2 cosine of x is equal to 3. Then cosine of x is equal to 3 over 2. Okay, and then x is equal to cosine inverse 3 over 2. Let's see if we have the value here. Okay, so inverse 3 over 2. Okay, it's undefined. So undefined. Okay, but anyway, we have one that works. Okay. Okay, next pair. Let's draw the x chart again. Negative 36 and negative k. Okay. Now the next pair is 3 and negative 12. So you have 3 and negative 12. Again, divide each of this number by the leading coefficient 12. So 3 over 12, right? 3 over 12, and then now negative 12 over 12. And then write this in its most simplest form, right? That would be 1 over 4. That would be negative 1 over 1. Now let's write the potential factor form here. 2 times here. This one will be 4 cosine x now plus 1 times 1. So cosine of x minus 1. Now notice that this will be a problem because 4 cosine x times cosine of x is just 4 cosine square x times 2 will be just 8 cosine square x. In fact, we have 24 cosine square x. So now, in this case, I just have to just keep this 3 over 12 here. So let me rewrite this. So that would be 2 times, let's say, 12 here. 12 cosine x plus 3 times, now, cosine of x minus 1. Okay, in that case, this will give you the original quadratic equation here. Now, divide both sides by 2. We get 0 equals to 12 cosine of x plus 3 times cosine of x minus 1. And that means 12 cosine of x plus 3 equal to 0, or cosine of x minus 1 equal to 0. Now, let's make sure that we have a value for x here. So in this case, subtract 3 from both sides. 12 cosine of x equals to negative 3. Then cosine of x is equal to negative 3 over 12. Okay, then x is equal to cosine inverse negative 3 over 12, and that is equal to approximately 104.48. Okay, that's just a rounding value. Okay, now this one as well, let's try it. Cosine of x is equal to 1, right? Add 1 to both sides. Then we have x equal to cosine inverse 1, and that gives you 0. Okay, okay, so it has two values here. Now, next pair. Let's draw the x chart again. Negative 36 and negative k. Now, this time will be the last pair because we don't have to do any work further on 6 or negative 6 because we determined that it's not the value. Okay, so now last pair, 4 and negative 9. Okay, so 4, negative 9. Again, divide each of this number by its leading coefficient, so 4 over 12. This one will be negative 9 over 12. And then write them in the most simplest form. This one will be 1 over 3, and that will be negative 3 over 4. Now, the potential factor form is 2 times, now 3, cosine of x, now plus 1, times 4, cosine of x minus 3. Okay, now divide both sides by 2. 0 equals to 3 cosine of x plus 1 times 4 cosine of x minus 3. Now that means 3 cosine of x plus 1 is equal to 0, or 4 cosine of x minus 3 is equal to 0. Now, we have to make sure that that's a value for x here. So for this one, subtract 1 from both sides. 3 cosine of x is equal to negative 1. Cosine of x is equal to negative 1 over 3. Then x is equal to cosine inverse negative 1 over 3. And that's approximately equal to 109.47. Okay, for this one, let's try it out too. So we have, we add 3 to both sides. We have 4 cosine of x equals to 3, and cosine of x is equal to 3 over 4. X is equal to cosine inverse 3 over 4, and that is equal to 40, approximately equal to 41.41, right? So these are rounding value. Okay, again, it has two values. So it seems like each of this pair have at least one value that works for x, right? So they probably work, right? Like, so this value here, this potential k value here, probably are all okay. Okay, but anyway, let's just validate all of them, okay? So here, let's try that. Here. So when k is equal to 35, right? We have this value here, right? 94.78. So sine 2x, right? So sine 2 times 94.78, right? Divide by 6, right? That's the left side of the equation given in the question. That is approximately equal to negative 0.02768. Now, let's try the right side of the equation. Sine 3x, so 3 times 94.78, right? Divide by, now, k, right? This is k. So we say that this is 35, right? As the first pair, okay? Negative 36 plus 1 is negative 35. Then negative k is equal to negative 35. Then k is equal to 35, right? Okay, so now, in that case, that would give you approximately negative 0.02768, okay? Okay, so here, the values are the same. So that shows k equals to 35 works. So this one works, okay? Now, k equals 16, okay? K equal to 16. Let's validate this. Now, sine 2 times, right, sine 2x, right? So sine 2x times 90, in this case will be here, right? This is for the 16 value, okay? So 99.59. So 99.59 divided by 6, right? That's the left side of the equation given in the question. And you guess, okay, no, negative 0.054756 approximately, right? Okay, try the right side of the equation, okay? So sine 3x, so 3 times the x value is here, right? 99.59. So 99.59. Or divide by, in this case, is k is 16, okay? So we have this approximately equal to negative 0.05478. Okay, now notice that this is a slight difference here. That's the rounding difference, okay? Because the x value 99.59 is just approximate, okay? So that works, right? So it's just a rounding difference here, okay? Okay, so it shows that k equals 16 works as well. Now next, k equals to 9. What k equals to 9? Sine 2x, and x would be, for this case, right? This is for k equals to 9, okay? That will be, x will be 104.48. So 104.48 divided by 6. That's the left side of the equation. And that gives you approximately negative 0.0806998. Now, for the right side of the equation, right, sine 3x over k. So sine 3 times, x is here, right? 104 and 48. So we have 104.48. Well, that's approximate value only. Divided by k. K in this case is 9. Okay, that would give you approximately negative 0.0806998. A06772. Okay, again, it's just a slight difference here. That's the rounding difference because 104.48 is just approximate value, okay? Now, this one here has two value, right? So x can be 0. Okay, but if you put, yeah, if you put 0 here into x here, right? If you put 0 into x here, both numerator is sine 0, and that gives you 0. 0 over 6 is 0. 0 over k is 0. 0 over 0, okay? So we don't have to test that out. That's fine. Okay, next, we're going to try to validate. Oh, we did say that 9 is okay now, right? So validate k equals to 5, okay? So k equals to 5. We have k equals to 5, right? Then sine 2x, so sine 2 times what's the x value for k equals to 5? Will be this pair here, okay? So it's like first value is 109 and 47, approximate value, okay? So 109.47 divided by 6. What value did that give you? Approximately negative 0.10475. Okay, on the right side, sine 3x over k, right? So sine 3 times x is 109.47, approximate value, okay? Divide by k will be 5 in this case, and that will give you negative 0.104767 approximately, okay? Again, there's a little bit of rounding difference because, again, 109.47 is just approximate value. Now, we have two value too, right? For this pair, okay? So we will try the 41.41 out for x, okay? So let's do this. Okay, is equal to 5. Sine 2 times 41.41, right? Divide by 6. That's the left side of the equation given. That's approximately equal to 0.16536. On the right side of the equation, sine 3x over k, right? So sine 3 times 41.41, right? 41.41 is also approximate value. Divided by k, k is 5 here. That will give you approximately equal to 0.16536, okay? Okay, so, right, this works too, right? So this just show that k equals to 5 works as well. Okay, so these are the k values that will satisfy this equation here in this question, where k is positive integer. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.